Hey there, science fans. Have you ever made lemonade from those little flavor packets? You mix the powder into water and poof, it disappears. But it doesn't really vanish, does it? That's dissolving in action. Think about dropping salt in your soup for extra flavor, or stirring sugar into your tea to make it sweet. These are all examples of dissolving we see every day. Pretty cool, right? What's happening is a bit like a magic trick, but with a scientific explanation. It's all about how different substances interact at a tiny, invisible level. Dissolving is a fascinating process that's vital to our world. From the salt in our oceans to the medicine we take, dissolving plays a huge role. So get ready to dive in as we explore the science behind why things dissolve. So what exactly is dissolving? Imagine you've got a Lego castle, that's the solute, and a big tub of Lego bricks, that's the solvent. When you drop the castle in the tub, its bricks get mixed up with all the other bricks, right? That's kind of like dissolving. The castle, or solute, seems to disappear, but it's still there, just broken down into smaller pieces and spread out among the other bricks, or solvent. In scientific terms, dissolving is when a solid, the solute, breaks down into tiny particles and mixes evenly with a liquid, the solvent. It's like a big dance party where everyone's mingling and having a good time. The result is a special mixture called a solution. Now, you might wonder how this mixing happens at a microscopic level. Well, it all comes down to attraction. The molecules of the solvent are attracted to the molecules of the solute. They surround and pull apart the solute molecules, kind of like tiny magnets. And voila, dissolving occurs. Now, let's crank up the heat. Ever notice how sugar dissolves faster in hot tea than in iced tea? That's because temperature plays a key role in dissolving. Think of it like this. When you heat something up, its molecules get all energized and start moving around faster. They're like tiny dancers going wild on the dance floor. This increased movement gives the solvent molecules more opportunities to interact with the solute molecules and pull them apart. So the hotter the solvent, the faster the dissolving. But temperature isn't the only factor in this dissolving dance party. The speed at which we stir our tea or soup also matters. Stirring helps distribute the solute throughout the solvent, just like a good DJ keeps the party going by making sure everyone's involved. It's all about increasing those interactions between the solvent and solute molecules. Stirring things up, more factors at play. Hold on, there's more to this dissolving magic show. Remember how we talked about the solute breaking down into smaller pieces? Well, the size of those pieces matters too. Think about trying to dissolve a sugar cube versus a spoonful of granulated sugar. The granulated sugar, with its smaller particles, will dissolve much faster. That's because smaller particles have more surface area exposed to the solvent, allowing for quicker interactions and faster dissolving. And just like you wouldn't use water to clean up an oil spill, the type of solvent we use also affects dissolving. Some substances are just better at dissolving certain things. For example, water is great at dissolving salt and sugar, but not so much oil or grease. That's why we use soap to break down those greasy messes. Different solvents have different properties, and that determines what they can and can't dissolve effectively. Dissolving in action, real-life examples. Let's take a dip in the ocean. Did you know that seawater is a solution? It's a salty mix of water and dissolved minerals. The water acts as the solvent, and all those minerals, like salt, get dissolved in it. That's why the ocean is salty. And how about those fizzy bath bombs? Drop one in your tub and watch as it dissolves, releasing colors and scents. The solid bath bomb, our solute, reacts with the water, our solvent, creating a fun, fizzy experience. Ever taken medicine that comes in a tablet or capsule? When you swallow it, the medicine dissolves in your stomach fluids. This allows your body to absorb the medicine and put it to work. From the ocean to our bathtubs to the medicine we take, dissolving is everywhere. The importance of dissolving from science to everyday life. Understanding dissolving isn't just for scientists in lab coats. It's important in so many aspects of our lives. Cooks rely on dissolving to make delicious soups, sauces, and drinks. Doctors use dissolving to create medicines that our bodies can absorb. And industries use dissolving in countless processes, from making paint to cleaning up pollution. So the next time you see sugar disappear in your tea or salt vanish in your soup, remember, The amazing science at play. Dissolving is a fundamental process that shapes our world in countless ways. Keep asking questions and exploring the world around you. You never know what fascinating scientific discoveries await.